Good evening, everyone. You are welcome to class. Today we are going to be looking at how to calculate distance on small circles. This is going to be a video you will love so much. I believe you are going to learn a lot. We've also done, just to give us informed, that there is a video we've done on how to calculate distance on great circle. Please try as much as you can to find that video and watch, so that you can be up to date with what we have done so far. All right, so without wasting much of our time, let's get down to this. How do we calculate distance on small circles? All right, so how do we actually calculate distance on small circles? Okay, just like we have known before and discussed earlier, that small circle is latitudes other than the equator. So whenever you have circles other than the equator, that is happen to be latitude angle, then we are going to be having small circles, and we normally denote their radius with a small letter r. Okay, so we have that the formula to calculate distance on small circle is given as theta over 360 times 2 pi r, where this r happens to be the r cos alpha. We also did a video on the relationship between the small letter r and the capital letter R. So just do well and find the video and watch. Also, I just want us to also understand that this alpha happens to be the latitude angle. So and the theta is the longitude difference, where our r happens to be the constant, which is 6400 km, is a calculated radius of the earth, except otherwise stated by the examiner. This is always a fixed number that we normally use whenever we are doing our calculations. All right, there is something I also want to tell us about distance on small circle. Just like we used to discuss that whenever we have two given points or locations on the earth surface, we normally have it such that either the latitude will be common or the longitude will be common. In other words, one of them have to be common, then the other one will be vary. So depending on the one that is fixed and the one that is common. But whenever we are calculating on small circle, we usually have our latitude fixed, common latitude, then varying longitudes. All right, so just like what I'm saying here, for example, this may be this is my a latitude. Okay, then we are going to have of course my prime meridian. I'm going to have my prime meridian, which is going to come like this. For example, this is my prime meridian, and we can also have other longitudes this way and another one this way. So what we are saying in essence is we are going to have this point of intersections on this small circle. This is a small circle, and of course this is center. This is where the meridian has the intersection with the common latitude. So we usually join these points and these points together. All right, so for example, if this is my P and this is my Q, the distance between P and Q, you will see clearly that is along this latitude, all right, which is along the small circle, or that you see, and it's quite different from that of the great circle, all right, or the equator. So we have that the distance given is usually theta over 360 times 2 pi r. Okay, where r is given as r cos lat. I normally use lat because just to make sure we not get confused that the alpha there is the latitude angle. So if I substitute that into the formula, I'm going to have theta over 360 multiplied by 2 multiplied by pi multiplied by my r, then cos alpha. So by the time we substitute this r for this, we are going to have this expression. All right, so let's try and take one or two questions and solve using this formula, so that we may have a better view and understanding of what we are discussing. All right, this is a typical question that is before us. In this question, we are given 2 points, P and Q. All right, You can see clearly here that we have our latitude fixed or common. You see them. I told you, whenever you are dealing with distances on small circle, this is one of the things that will give you a clue that this distance is on small circle, because you will see the latitude fixed, then the longitudes will vary. All right, so we have this. We have the radius that is given to us to be 6400 km. We also have our pi, which is 3.142. And so what was the question asking us to do? The first question is saying that we should calculate the radius of the parallel of latitude through P. All right, so that means this point P is what the examiner is saying we should calculate the radius. All right, the first thing we do is to draw, to locate these 2 points on the Earth's surface. All right, now because I'm having varying longitude, I told us whenever anyone is varying, you have to draw the reference line of that particular thing. I told you it's not wrong to also draw the equator, but I also say that it's always good to just focus so that our diagram will not be too cumbersome and start getting confusing. So it's just good to stick to this. This is my my prime meridian now of 0 degrees. Yeah, why did I do this? Because I want to draw other longitudes, and this must be the reference line in which I will use to draw other longitudes. All right, so to locate my P now, I discovered that there is a common latitude which is towards the northern hemisphere, which is 32 degrees north. So all right, let's assume I have a convenient. Let's assume this is my 32 degree north. Okay, of course this is my prime meridian intersection with that common latitude. Then on the other hand, to locate my P, I have 47 degrees west. All right, so I take my arc again, draw my line of longitude towards the west side. All right, so this point of intersection happens to be my point P. And then on the other side, I have 28 degrees east. All right, so if I draw that again towards the eastern side, okay, sorry, towards the eastern side, I'm going to have, let's assume this is my 28 degrees east. So where the point of intersection is also going to be my Q. All right, so when I complete this circle, this small circle, of course, you'll be able to locate the center. All these lines will be joined. We join this to this, join to this, and join this to it. Actually, it ought to be a straight line. So from here, I have this angle, and from here, I also have this angle. All right, so the distance PQ, you can see clearly that is along this small circle. All right, so what was the question asking us to do? The first thing we have to do here is to calculate the radius of the parallel of latitude through P. All right, so how do we do that? R is given as capital R cos lat. All right, so that's cos alpha, which happens to be the latitude angle. All right, so R now is going to be 6400, we are given in the question, multiplied by cos, and the latitude is 32. We have 32 degrees. All right, so when I pull up my calculator, what I'm going to have 32, the cos of that angle, multiplied by 6400. All right, this is going to give me 5427.51 approximately, to 2 decimal places. I'm going to have 5427.51. So I have 5427.51 kilometer to 2 decimal places. All right, that's that. Then the second question is to calculate the distance between P and Q along the parallel of latitude. So how do we do that? Distance is given as, so whenever they use the word along the parallel of latitude, they're actually saying along the small circle. Please, let's just bear that in mind also. That's another way they can ask the question. All right, so without wasting much of our time, you will see that this R that is here is same thing as R cos alpha, where alpha happens to be the latitude. You see, it's the same thing with this expression that we have gotten before. So another thing that we need in this formula is our theta, so which is the longitude difference. So we also have to calculate the longitude difference. So how do we get the longitude difference? How do we do that? So how to do that is simply to watch the longitudes. We have 47 degrees west, we have 28 degrees east. Just like the previous video, I told us when the direction is the same, you subtract. But when the direction is different, we simply add. Maybe when we have east-west or west-east, you add it together. All right, so in this case, we see that they are of different direction, one to the west, the other to the east. So we're simply going to add. Okay, so how do we add that? We are going to say 47 added to 28. So when we do that, this is going to give me 5. It's going to give me 7. So we have 75 degrees. So my theta is equals to 75 degrees. All right. So now let's now go straight to the question proper. The question is saying that we should find the distance. So distance now is 75 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by the r. But we've gotten the r before, and the r is 54. We have it to be 54. Let's quickly check that up. We have it to be 5427.51. all right, so 5427.51 was our value, 27.51. all right, so this is what we have. So when we do this, what are we going to get? Let me pull up my calculator now. I'm going to have 75 divided by 360. Okay, that is going to give me this, then multiplied by 2 multiplied by 3.142 multiplied by 5427.51. And our answer is 7105.52. 7105.52. So we have 7105.52 kilometer as the distance along the parallel of latitude, as we are told to do. All right, so the third question also says that now the big question of that particular question says, if it takes an helicopter 9 hours to travel from P to Q, calculate its speed correct to 3 significant figure. All right, so of course we know that speed is given as the distance divided by time. Okay, so already we have our distance to be 710 days 0.52. So divided by the time that we are given. Okay, when we do that, that means this very answer divided by 9, that is going to give us 789.50. all right, 789.50. okay, so we have 789.50. Of course, speed is measured in kilometer per hour. Okay, because this is in kilometers and this is in hours, so we have kilometer per hour. All right, I believe you enjoyed this video. This is just the solution to that question. I believe we've learned one or two things concerning this question. So whenever we are giving a similar question like this, it's just the same procedure. Just be sure that you substitute the right parameters as required. All right, once that is done, are you able to know that your r is days, you see, then it becomes easier for us to be able to solve the problem. All right, so we are going to take another question now, just for us to gain mastery. So let's just go to the next question. I believe you are enjoying this video. Please kindly like, share, and subscribe to our channel. I believe there is a lot for you on this channel, and I believe you will not regret subscribing or being a part of us. Thank you very much. So let's quickly go to the next question now. Okay, so this is the second question we'll be looking at. We are given point A and B and also C, and we are told that 3 places on the Earth's surface we have to calculate correct to 3 significant figures. All right, so they told us they want us to specify three significant figure. Okay, the distance AB along the latitude. You see, they mention latitude. Okay, and the distance BC along great circle. Okay, we are told BC is along great circle. Then also the time taken by an aircraft to cover a distance AB and BC if the speed of the aircraft is 750 kilometer per hour. All right, so let's get down straight to this. We can see obviously that our latitude is the same. So we have a common latitude towards the northern hemisphere. Let's say this is my latitude of 75 degree north. All right, so I have longitude. So what do? I take my prime meridian. Okay, I haven't done my prime meridian. Then I want to locate point A now, which is along 25 degrees east. So I come to the eastern side and I draw my arc. Okay, so this location, that's my point A. Okay, to locate point B now is 29 degrees west. Okay, so I'll come to the west direction also, and I have another point here, okay, which is my B. Okay, then we complete this. Of course, we complete very quickly. After completing this, then we join the intersections to the center. Oh no, sorry, we join the intersection to the center. Maybe I should use my okay, maybe a straight line will help us to, because I want us to see this very properly. Okay, so from here we have a line to this point. Okay, we have a line to this point. We also have another one from here to here. Okay, we have another one from this point to this point. Okay, so you see, you join this point this way. All right, so having done that, then we have another point C, which is the latitude. This, you see, the latitude 48 degrees south. So we have latitude 48 degrees south, and so if I take latitude this 48 degrees south, okay, and the longitude is 29. So is this longitude, this 29 degrees no, this one, they said 29 degrees west, 29 degrees west. You see, it's the same longitude with that of B. So we are looking at somewhere around here, okay, to get my C. All right, so we can see how the whatever is traveling, maybe aircraft or wherever, yeah, is the aircraft. So move from A to B. You see, A to B is along the small circle. Then we now move from B to C, which is along the meridian. That's great circle. So you can see the diagram has helped us to be able to know how to do the calculation. So you are not going to use the same formula to calculate the distance, these two distances. No. The distance between A and B is along the small circle, while the distance between B and C is along the great circle. That's the meridian. So you see the formula is going to change. All right, so the first thing we have to do is to calculate the distance between A and B. All right, so distance between A and B, as we can see from the diagram, is along the small circle. All right, so how do we calculate that? We say theta over 360 is multiplied by 2 pi r. Okay, so where we have our r to be equals to capital R cos alpha. All right, where alpha happens to be the latitude. All right, so the next thing we need to find is our theta. Theta happens to be the difference in longitude. All right, so you look at the 2 points A and B. So we can see 25 degree east and 29 degree west. So they are of different directions. So we add them together. So we have 25 added to 29. So when we do this is 4. This is 54. All right, so we have 54 degrees. So now our formula, the distance between A and B is now going to be 54 divided by 360 multiplied by 2 multiplied by 3.142. They didn't really specify for this. Okay, so 3.142 multiplied by, of course, the 6400, 6400, then multiplied by cos. Now their latitude, their common latitude is 75 degrees. Okay, so let's get down here and express it very well. So when we bring out our calculator to quickly do that, we are going to have 54 divided by 360, then multiply by 2. Okay, maybe I should just do it this way, because okay, multiply by 2. Sorry, let's just start like this. I'm trying to see what's cos. This is 75. If I take the cos, this is my calculator. It's, you know, I need to just go gently with it. So I have 0.2588. okay, 0.2588. That's the value of this 0.2588. all right, so this is going to help me to multiply better. All right, so I have let's quickly do that. 54 divided by 360, okay, then multiply by 2, multiply by 3.142, multiplied by 6400, and then finally multiplied by 0.2588. all right, so that is giving me 1561.25. okay, 1561.25. all right, so I'm having 1561.25 kilometers. So this is the distance between A and B. all right, so question 2 is saying that the distance BC, you see, distance BC obviously is along the great circle. So the formula for BC is going to be theta over 360 times 2 pi capital R now, because it's on the great circle. all right, so we have to find our theta, because theta is not going to be the same. Okay, because obviously if I want to do this, you see, this is going to, if I want to get the angle of this very one, because I can now see 2 latitude, this is my equator, and because it's along the great circle, of course it will have its radius on the surface of the earth. So you see there is point of intersections that we can see. Okay, sorry, down here we see here and we see here. Okay, so but we can see BC, we are talking about B and C. So B and C. all right, so if I join from B down to the center and from C down to the center, then of course I'm going to join to this. The line is not very straight, but I believe we are getting it. So we are going to join this to this. Sorry, it's going to come to this line I have here, I have here also. So we are looking at this angle and this one all together. Okay, so we are going to find that angle, and in order for us to get the angle, we are going to examine the 2 points. This is point C and this is point B. So what do they have in common? The longitude is common, but the latitude varies. all right, so we have 75 degrees north and we have 48 degrees south. So different direction, we simply add. So we have 75 added to 48. So this is going to give us 13. Then this is going to give us 11 plus that's 12. Okay, so we have 1, 2, 3. 1, 2, 3. So 1, 2, 3 degrees is equals to our theta. all right, so 1, 2, 3 is equals to our theta. all right, so let's now quickly just rush this up to find the distance. We are looking for the distance now, the distance between B and C along the great circle. We can have 1, 2, 3 degrees divided by 360 times 2 times 6400 times okay, pi. Okay, I've omitted pi, so let's assume this is my pi. I believe you still remember the formula that I'm using, theta over 360 times 2 pi r, where r happens to be the bigger r. All right, so let's quickly do this. I'm having 123 divided by 360. That is going to give me this. Then multiply by 2, multiply by 6400, multiply by 3.142. All right, so that is 13741. 13741. 13741. Okay, so we have 13741, of course, point, maybe point this. Okay, kilometer. So this happens to be the distance between B and C along the great circle. All right, then the last question to ask us to find the time. We have to find the time. It said find the time that we take the aircraft to cover the distance AB and BC. The distance AB and BC if the speed of the aircraft is 750 kilometers per hour. All right, so before we do that, we have to add up the distances between AB and BC. So we add them. We've actually gotten that the distance between AB, we got it to be 516125. 516125. So the distance, total distance travel now. So the total distance traveled is now going to be distance of AB added to the distance of BC. All right, so sorry, let me pick that again. We have 156125. okay, is 156125. That's the distance that we got for this one. 5161.25, then added to 3741.01. okay, so we are going to add this together. So let me just show this. Okay, so when we do this, we are going to have, we already have this, so we are going to add it up to sorry, I want to be able to see clearly. Okay, so plus we are adding it to 516125. So plus 5161.25. okay, and that's giving us 18,902. 18,902. So we have 18,902 point. I think there's a point there. Okay, 62. 26. All right, so this is the total distance. All right, so how do we calculate time? We know that speed is equals to distance over time. All right, so if we make time the subject, time will now be equals to distance over speed. Okay, so our distance is 18902.26, then divided by the speed, which is 750. We are actually giving in the question. So this is the answer divided by 750 will give us the time. Okay, divided by this, we are having 25.20. okay, 25.20. all right, so which is equals to 25.20 hours. Of course, it's going to be in hours. That's the time. So approximately it's going to give us 25 hours. So that's what we take the aircraft to travel. And I also think the examiner was saying something specifically on how, I think it says that, yeah, it said calculate correct to 3 significant figures. This, so the distance, are we taking it to 3 significant? So 1, 2, 3. If this we go to 3 significant figures, so we definitely know what to do, right? That's going to be 1560 kilometers. So that's what we are going to take that to 3 significant. I believe you are enjoying this video. Thank you. So we are going to take another question again. Please stay tuned as we go forward. Thank you very much. Okay, so this is the third question we'll be solving. The question says X and Y are 2 positions on the Earth's surface of latitude 72 degrees north. Their longitudes are 23 degrees east and 107 degree west respectively. So calculate the distance between x and y measured along 1, the parallel of latitude, and 2, great circle. All right, so we can see that we are told that the two positions on the earth surface, that they have the latitude of they have a latitude of 72 degrees north. So that's their common latitude. So we come to the northern hemisphere, we have 72 degrees north. Okay, then what other thing are we to do? We have to locate 23 degree east. So we have 23 degree east, towards the east is 23. Okay, then we also have 107 towards the west. Okay, as soon as our 107 degrees west. Okay, all right, so now what other thing do we have? Now let's complete this. Just like I've told us, I've drawn two longitudes without my prime meridian. So no, in fact, this should be the first thing we draw, so that because it's from here we reference other ones. All right, so of course the one for the, because they say respective, so this is my x is the one of 23 degrees east, so this x, and y is 107, so this is my y. Okay, so this is the center for this, so we have this to this, we have this to this, and then this to this. I believe we cannot draw the diagram very well now. Okay, so of course this is my prime meridian, which is 0 degrees. All right, so what are we to do? We have to calculate the distance between x and y measured along the parallel of latitude. So they told us, just like I said, whenever they mention parallel of latitude, they are simply saying along the small circle. All right, so that means theta, the distance along parallel of latitude, is going to be theta over 360 times 2 pi r. Okay, so let's find our theta. So theta is going to be which is the longitude difference. We look at it, this one is to the west, the other is to the east, so we are simply going to add. So we have 107 added to 23. Okay, this is 0, this is 3, and this is 1. All right, so we are having it as 130. All right, so that's 130. So what will be the distance along parallel of latitude? Is going to be 130 divided by 360 multiplied by 2 multiplied by they're not giving, so let's just 1.42 multiplied by the r cos lat now, so 6400 times cos of course, what was their common latitude? That's 72 degrees. Don't forget that this r is r cos alpha, where alpha is the latitude. All right, so we do this, what are we going to get? We are going to have, let me show you clearly here. So we have 130. Let me first of all do 72, the cos of that side. Okay, that's 3090. So the cos of this one is giving me 0.3090. Okay, now if I believe your calculator may be two display, so it can easily just take everything once. 130 divided by 360. Okay, then the answer multiplied by 2 multiplied by 3.142 multiplied by 6400, then finally multiply by 0.3090. Okay, so it's going to give us 4487.61. okay, so the distance is 4487 point, is that 30? No, 661. Okay, 0.61 kilometers. Okay, so this is what we have for the first question, which is along the small circle. All right, the second one is saying along the great circle. Along the great circle. So what's going to be along the great circle? The formula is going to change to theta over 360 times 2 pi capital R. So this is what we are going to have now. So in this case, we are not going to have a cos of any angle. It's just going to be a direct one. So of course, our theta will not change because it's still the same. It's still the same angle we are considering. So our theta is not going to change. So maybe let's just come up here and just do that. So question 2, we are looking for the distance. And that means we are still going to use our 130 degrees divided by 360 times 2 times pi, of course, then times 6400. So this is what's going to be the distance. So when we do this with our calculator again, we are going to have 130 divided by 360 multiplied by 2 multiplied by 3.142 multiplied by 6400, and that's going to give us 14,523. 14,523. So we have 14,523. I think there is a decimal. Let's check. 0.22. Okay, so we have 0.22. Okay, they didn't tell us what to, so let's just say to the nearest kilometers. We are going to have let's say 523 kilometers. Okay, so and that is the answer for this. You see, along great circle, they just mentioned it, so we decided they just want to see whether we have the understanding of great circle, how to calculate distance along this. And for this other one, along the parallel of latitude, we have to use this. Along great circle, we have to use this very formula. So I believe you find this interesting, and I believe by now everybody should be able to calculate distances on small circle and on great circle, of course. So we are going to be going to the next topic now, our subtopic under this particular one, and we're going to be looking at how do we calculate distances in nautical miles and in knots. So I believe you are also going to find this one interesting, in case you are to calculate how do we calculate distances in knot, or speed in knots, and distances in what we call the nautical mile. Okay, the nautical mile. So it's very interesting. It's something we ought to know, and I believe we are going to enjoy that video also. So thank you for watching. Please like, share, and subscribe to our channel as we bring more to your doorstep, and we take you step by step even towards this particular journey. God bless you. Thank you for watching.